Okay, if you're watching this video, you should be an Algebra I student, and it should be Thursday, February 11th. You could be watching this for one of two reasons. One, it's an e-learning day, and we're sitting home snowed in or iced in. Or two, the weather missed us or it cleared up or whatever. You're in person or you're virtual, and I'm not here though, right? I'm going to take this day off. I'm going to a baby doctor appointment. So you'll watch this video and then work on your homework. This will probably be the easiest thing you do the rest of the year. I hope beyond hope that this is review for you. Section 7.2. That's called something a little bit different. It's like powers of 10 in scientific notation. I don't really care about the powers of 10 stuff. We are going to just review the scientific notation. So we are going to start in scientific notation and convert it to a number in standard form. Standard form, it will be just a regular old number. And then we'll start in standard form and go back to scientific notation, okay? Scientific notation in general is a times 10 to the n. A has to be between 1 and 10. It can equal 1, but it cannot equal 10. Little throwback to chapter 3 there, where we dealt with compound inequalities. N has to be an integer. -3, -2, -1, 0, 1, 2, 3, any of that kind of stuff, okay? If n is positive, if n is positive, move the decimal to the right. If n is negative, you're going to move the decimal to the left, right? So if n is positive 4, 4 to the right. If n is negative 12, 12 to the left, okay? So let's start with something like 1.823 times 10 to the 7th. So that number is between 1 and 10, so check, times 10, check, integer. So we are in scientific notation. So what I would like you to do is rewrite the a value and then show the movement. 1, 2, 3, 4, 5, 6, 7. Where these empty spaces are, fill in with zeros. Do not leave your answer like that. Nobody writes a number with a decimal that's in the wrong spot and arrows that don't. Okay, and it's usually boys. Boys are always the ones who want to leave it like this. Don't do that. So rewrite it without all the busyness. And then go back and add commas. So 3, we end up with 18,230,000. Number 2, we have something like 9.41 times 10 to the 12, might as well. So we have 9.41, and then we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So fill in all those spaces. Then rewrite it nice and neat. So that ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go back and fill in your commas. Let's see, million, billion. So that's 9,410,000,000,000. That number is not even a third of our national debt. That gives you any idea how big our national debt is. That's kind of scary. All right, number 3. We have something like 4.28 times 10 to the negative 5th. So now our exponent is negative, so we're going to take that decimal and move it to the left. 1, 2, 3, 4, 5. When you rewrite it, don't forget to put your decimal out front. Okay, so we get 0.0000428. Always get paranoid that I forgot to hit record. Okay, I did. Number 4. Let's do 8 times 10 to the negative 6. So when you do this, the decimal is always on the side. 1, 2, 3, 4, 5, 6. Fill in with zeros. And we get 0.000008. I want to do just one more up here. I want to have one with a positive just so I can bring up a point. Let's just do 8.2 times 10 to the 4th. Make it short and sweet. 1, 2, 3, 4. So we get 82,000. What you should notice is that every time our exponent is positive, our final number in standard form is bigger than 1. And every time we do one where our exponent is negative, our final number in standard form is smaller than 1. I bring that up because when we go the other direction, start in standard, go to scientific notation, if your original number is smaller than 1, you're going to end up with a negative exponent. If your original number is bigger than 1, you're going to end up with a positive exponent. Okay? It's going to feel weird because we're going to have to move the decimal to the right, and you're thinking, well, right means positive. But you got to think about when you undo it, you need to go left, and that's why it's negative. Okay? So let's go from standard to scientific notation. So if I have one that is 0.0049, that number is smaller than 1, so I know that my times 10 is going to be to a negative exponent. And I need to pick up this decimal and move it until I'm between 1 and 10. So 1 time, 2 times, 3 times. So that means that'll be a negative 3. And my new number is going to be 4.9 times 10 to the negative 3rd. All right, number 6. If I have 834,000. Okay, my decimal is currently here. That's bigger than 1. So it's going to be times 10 to a positive number. And then I have to move until I'm between 1 and 10. So if I move it here, I'm at 83,400. If I move it here, I'm at 8,340. Now I'm at 834. Now I'm at 83.4. Now I'm at 8.34, which is between 1 and 10. I moved it 1, 2, 3, 4, 5 times. So I get 8.34 times 10 to the positive 5. Number 7, let's do 1 billion. So obviously it's bigger than 1. So I'm going to have a positive exponent. I move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So I'm going to get 1 times 10 to the 9th power. Number 8. Let's do 0.00004008. I have a number that's smaller than 1, so I'm going to have a negative exponent. And I need to move it 1, 2, 3, 4, 5 times. Don't leave out this 0.008. You have to write everything after as well. Sometimes people just give me the 4 and they'll leave off this stuff. That was smaller than 1, so like we said, that would be a negative exponent, and that would be -5. Some of you might be thinking, well, what would I do if my original number was negative? Do everything like you would normally do, and at the end make it a negative number. Okay. So technically, it's the absolute value of A has to be between 1 and 10, but whatever. All right, I think that's plenty of examples. You guys have done scientific notation a gazillion times in your life. You're probably wanting to get started on your homework, so there's no reason to make you wait much longer. Let's do section 7.2, and let's do 21 through 24. '30 through 35. And let's do 29. I know that's kind of out of order there. 29 and 44. Okay, so you have 21 through 24, 29, 30 through 35, and then 44. So it shouldn't take you too long to get those done. All right, I'll see you guys hopefully tomorrow. If not, we have another e-learning day. Whichever way, I'll see you then.